Okay, we want to find the work required to pump this water out of this tank. So we have a inverted conical tank here that with a radius of 4 meters and a height of 5 meters, and the water level is currently 3. So the idea is we're going to have to take this water here from the inside of the tank up over the edge and out in order to empty this thing. So we remember that work is force times distance, and so we have to ask, where are things constant here? Because uh, the water at the very top here doesn't have to go very far to get out, whereas the water at the bottom has to go further. And so the way we would slice this so that the work is constant along a slice is horizontally, right? So if we take a little slice of water here, all this water has the same distance to go to get out of the tank to be lifted up to that height. So we know that the density of water is 1,000 kilograms per cubic meter, and so to find a mass, we're going to need the volume of this slice. For that, we might turn this picture sideways and just look at it straight on. And so we know that the radius of the big cone is 4 meters, and the height of the cone is 5. And if we look at one of these slices here, what we really need is the radius of this slice in order to find the surface area and then the volume. Now, the other thing we need is a variable to represent where we're slicing, and for that we can either measure from the top down or from the bottom up. In this case, I'm going to go ahead and use this measurement here. I'm going to call it y. It corresponds with this distance here as my variable. Now we can use similar triangles, because this triangle here is similar to this larger triangle here. So for the large triangle, the width of 4 in relation to the height 5 will be the same as the relationship of the width r to the height y for this smaller triangle. So solving that for r is 4/5 y, and now I can talk about the volume of my slice. Because it is circular, it'll be pi times the radius squared, right? The radius being this r value here, which we just found an expression for, times the height, which is that little thickness dy. So putting those together, the mass of the slice will be density times the volume, so 1,000 times pi times 4/5 y squared dy. And so then the force on that slice will be gravity times the mass, right? Mass times acceleration. And we're going to use 9.8 here for gravity. So 9.8 times 1,000 times pi times 4/5 y squared dy. And now we can talk about the work required to lift that slice. So for that one slice, the force is 9,800 pi times 4/5 y squared dy. That's our force. And now we need our distance that we're going to lift that slice. And if we look back at our picture here, to get to the very top of the tank, we're going to have to lift the slice this distance here, which corresponds to this distance here. Now, the entire height was 5. This distance was y, and so that leaves as the remaining distance 5 minus y. So 5 minus y is the distance that we have to lift the slice. We want to be consistent here in how we're using the variable y. So to find the total work now, we just integrate 9,800 times pi times 5 minus y. I'm just rearranging the terms here a little bit. 4/5 y squared dy from the bottom of the tank to the top of the water level, so to a y value of 3.